Good day everyone! I am Kate Valerie Barrera, and for this topic, I will discuss about gas chromatography. So gas chromatography determines how many chemicals are present in a sample and separate each compounds in a further study. Gas chromatography is constructed by various parts which are gas tank valve, gas tube, gas flow, GC oven, sample inlet, GC column, detector, and recorder. Now, coming to the details of various parts of GC instruments. The first part is GC tank, which is made up of stainless steel and contains gas. Gas can be used as a mobile phase, which may be helium, nitrogen, hydrogen, argon, carbon dioxide, and air. Amongst all of these gases, helium is most commonly used as a mobile phase. The next part of GC instrument is gas controller. It helps us to control the gas flow rate. In GC, pressure of gas should be in the range of 40 to 80 per square inch. Moving on to the GC oven, which is an enclosed chamber and used to maintain the temperature, especially in the high temperature, which it can be heated up to 400 degrees Celsius. Now, coming to the sample inlet, where we can inject gas or liquid sample. If sample is solid, then it will be dissolved in the liquid and converted it into the liquid sample and then injected. Next part of GC instrument is GC column. Two major types of column are available. The first one is capillary column, and the second one is pack column. Generally, capillary column is used in GC length will be 1 to 300 meters. Internal wall of this capillary column is coated with high boiling point stationary phase like silicon polymer or ethylene glycol. Now, let us understand the various detectors used in gas chromatography. Various types of detectors used in GC are thermal conductivity detector or TCD, flame ionization detector or FID, electron capture detector or ECD, thermionic specific detector or TSD, flame photometric detector or FPD, photoionization detector or PID, and mass spectral detector or MSD. MSD is most sensitive detectors among all of these detectors. Now, coming to the working of GC instrument, first we will open the gas tank valve, then set the pressure of gas mobile phase at 40 to 80 per square inch. Gas mobile phase will be flowing into the GC column. After that, we will inject the sample into the sample inlet. If sample is gas, then gas syringe will be used. If sample is solid, then it will be dissolved in the suitable liquid and converted into the liquid sample. If the sample is liquid, then we will inject the sample through the microsyringe at the sample inlet. If the gas column is injected, then it will directly go towards the column along with the mobile phase for the elution like this. But if we are injecting the liquid sample, then it will be converted into the gaseous form due to the heating created by the heated metal block present in the sample inlet part. It works like this. First, the chromatography instrument vaporizes a small liquid inside a special chamber, keeping the resulting gas through a heated column with the help of inert carrier gas, also known as the mobile phase. A liquid stationary phase inside the column slows the gas molecules as they pass through the column. Depending on their size and other properties, different pass through the stationary phase at different rates, emerging by the column one by one. Just before the compound exits the instrument, it passes through a detector that records the time and relative quantity of each substance. The detector sends an electronic signal to an amplifier which prints a chromatogram representing the exit time and amount of each compound with a series of peaks. Comparing these peaks to the patterns known to be produced by certain substances, narcotics, for example, offers clue to the composition of the original sample. That is all for my discussion about gas chromatography. Once again, I am Kate Valerie Barrera and thank you for